Centuries, the map of global power was drawn with oil pipelines, shipping lanes, and steel production. But in the 21st century, a new resource, invisible to the naked eye, is redefining the boundaries of influence. It is not a mineral, but a capability, the power to compute. The race for artificial intelligence dominance is not just about clever algorithms or vast datasets. It has become a physical, geopolitical struggle for the hardware that makes it all possible. This is the story of compute diplomacy, a deliberate, sophisticated American foreign policy strategy where access to artificial intelligence chips and the data centers that house them is being used as both a carrot and a stick. How did the United States acquire this powerful new lever of influence? What does this new diplomacy look like in practice? And what are the profound and potentially unintended consequences for the entire world? To understand this new era, we first need to understand its foundational resource, compute. In simple terms, compute is the raw processing power required to train and run advanced artificial intelligence models. It is the fundamental, non negotiable input. Think of it as the new oil. Like oil, compute is scarce, controllable, concentrated in the hands of a few, and absolutely vital for both economic prosperity and military power. The value of this resource is staggering. Artificial intelligence companies like OpenAI reportedly spend nearly 10 times more on securing compute power than they do on employee salaries. Let me say that again. Artificial intelligence companies like OpenAI reportedly spend nearly 10 times more on securing compute power than they do on employee salaries. The reason for this spending is a simple, almost linear relationship. The more compute you apply to an artificial intelligence model, the better it performs. This makes access to computational power the single greatest bottleneck for progress in artificial intelligence. He who controls the compute controls the future of artificial intelligence. This is not an abstract concept happening in the cloud. It is a physical arms race. Around the world, a data center building spree is underway, with construction spending in the US alone hitting an all time high of $40 billion in a single month. The total investment required to meet the global demand for artificial intelligence data centers is projected to exceed $5 trillion by 2030. And this infrastructure is incredibly thirsty. The United States Department of Energy predicts that artificial intelligence specific electricity use will grow at a mind boggling 33% each year. Data centers alone could triple their share of national power consumption in the United States by 2028. This has created a new geopolitical reality. A nation's ability to lead in AI in artificial intelligence is now directly tied to its ability to build and power these massive facilities. The discourse around artificial intelligence often focuses on intangible software and algorithms. However, the core of this geopolitical struggle is brutally physical and resource intensive. It involves massive construction, staggering energy consumption, and highly complex supply chains for tangible hardware. And it is this very physicality, this reliance on physical infrastructure, that transforms artificial intelligence from a purely technological issue into a geopolitical one. Because unlike an algorithm, which can be copied, or data, which can be shared, a physical chip and a data center that houses it can be controlled. The United States' ability to wield compute as a diplomatic weapon does not come from controlling every piece of the puzzle itself. Instead, it comes from its position at the center of a fragile, highly concentrated global supply chain and its ability to influence the few key choke points within it. It starts with design. American companies are the undisputed leaders in designing the advanced chips, or GPUs, that power artificial intelligence. NVIDIA alone is estimated to control between 80% and 95% of the entire artificial intelligence chip market. But these designs are useless without the machines to manufacture them. This brings us to the single most critical choke point in the entire digital world, a Dutch company called ASML. ASML has a 100% global monopoly on a technology called extreme ultraviolet, or EUV lithography. These bus-sized multi-hundred-million-dollar machines are the only ones on Earth capable of etching the microscopic patterns required for the most advanced Semiconductors. Yes, yes. With a technology called extreme ultraviolet. Without ASML's machines, building a cutting edge chip factory is physically impossible. The final step is fabrication. The designs from America and the machines from the Netherlands come together in Taiwan. At the foundries of Taiwan Semiconductor Manufacturing Company, TSMC fabricates an estimated 90% of the world's most advanced logic chips for clients like Apple and Nvidia. This incredible geographic concentration makes Taiwan the linchpin of the global tech economy and a source of immense geopolitical leverage. This concentration of critical capabilities designed in the US, key equipment in the coalition in the Netherlands and Japan, and fabrication in Taiwan forms the basis of a powerful technological coalition. Recognizing this, the United States has not acted alone. Since launching its strategy, Washington has engaged in intense diplomatic efforts to align these key allies. In early 2023, it secured crucial agreements from both the Dutch and Japanese governments to implement their own parallel export controls, effectively creating a multilateral blockade around these choke point technologies. The United States does not control the entire supply chain directly, but its dominance in design and software combined with its diplomatic influence over these key allies creates a powerful system that some have called an underground empire. It is a system of weaponized interdependence where Washington can act as a spider at the heart of a global web, leveraging these intricate connections to exert influence far beyond its own borders. This is the very essence of the choke point strategy. The opening salvo in this new conflict was fired on October 7, 2022. The Biden administration, through the Department of Commerce, implemented a sweeping, unprecedented set of export controls. The stated goal was clear: to restrict the People's Republic of China's ability to both obtain and manufacture high-end computing chips as part of a broader effort to counter its military modernization. The strategy was described by National Security Advisor Jake Sullivan as building a high fence around a small yard, targeting only the most advanced technologies with direct military relevance while allowing broader trade to continue. To achieve this, the United States deployed a sophisticated toolkit of legal and regulatory measures. The first tool is the Commerce Control List. Think of this as a no-fly list for specific high-performance technologies. Advanced artificial intelligence chips like NVIDIA's powerful A100 and H100 GPUs were placed on this list, requiring a license for export to China, a license that would presumably be denied. A related tool, the Entity List, does the same for specific companies, effectively blacklisting firms like Huawei from receiving United States technology. The second and perhaps most powerful tool is the Foreign Direct Product Rule. This is the long arm of American law. It states that even if a product is made entirely outside the United States, say a chip fabricated by Taiwan Semiconductor Manufacturing Company in Taiwan, if it was produced using United States origin technology, software, or equipment, the United States government can block its sale to a restricted destination like China. This powerful extraterritorial measure closes loopholes and extends United States control deep into the global supply chain. Finally, there is the United States Persons Rule. This targets the most valuable resource of all: human expertise. This rule restricts U.S. citizens and permanent residents from providing support to certain advanced semiconductor facilities in China without a license. It is a direct attempt to stop the transfer of priceless knowledge and experience. But this initial strategy had a critical vulnerability. The rules focused on the physical export of hardware. They did nothing to stop Chinese companies from accessing the power of those chips remotely. This became known as the cloud loophole. A Chinese artificial intelligence firm, blocked from buying an NVIDIA H100 chip, could simply rent computing time from a cloud provider like Amazon Web Services in Singapore or Ireland and legally train its artificial intelligence models on clusters of the very same chips. Public tender documents revealed that numerous Chinese entities were doing exactly that. It was a glaring flaw that threatened to undermine their entire strategy. and it forced Washington to evolve. What came next was a profound evolution in strategy. In January 2025, the United States government unveiled its framework for artificial intelligence diffusion. This was not just another ban, it was the formalization of compute diplomacy. The policy shifted from simply denying technology to an adversary to actively managing and regulating the entire global flow of artificial intelligence compute, creating a sophisticated system of rewards and punishments designed to shape a new world. This framework divides the world into three distinct tiers for access to advanced computing. And the first tier is called the Inner Circle, and its 18 trusted allies, including the United Kingdom, Japan, South Korea, Taiwan, and key EU nations, they receive virtually unrestricted access to United States chips and technology. Then Tier 2, which is called the Battleground Group, the vast majority of the world, approximately 150 nations, their access is capped at a specific limit, roughly 50,000 advanced artificial intelligence chips through 2027. Then Tier 3 is the adversaries, and these are nations like China, Russia, and Iran. They are effectively blocked from importing any advanced artificial intelligence chips, continuing the status quo of strict denial. The true genius, or danger, of this framework lies in the diplomatic leverage it creates for the 150 countries in the middle tier. For them, the United States has created a powerful set of incentives. The message is simple: align with us, and you can get more compute. The template for this strategy was demonstrated even before the framework was formalized. G42, the leading AI firm in the United Arab Emirates, had deep ties to Chinese technology companies, including Huawei. United States officials, concerned that G42's data centers could become a backdoor for China to access advanced chips, engaged in months of negotiations. The result, in exchange for access to top-tier NVIDIA chips and a major partnership with Microsoft, G42 agreed to divest from its Chinese holdings and strip out Huawei technology from its systems. It was a direct geopolitical concession extracted using access to compute as the ultimate bargaining chip. The Artificial Intelligence Diffusion Framework formalizes this process through its validated end user program. A company in a tier 2 country can apply for this special status if it makes verifiable commitments to physical and cybersecurity and provides assurances that the technology will not be used for human rights abuses like mass surveillance. Its chips imports will no longer count against its country's national cap. This is a fundamental shift in strategy. The initial 2022 rules were about creating scarcity for an adversary. This new framework uses a system of managed scarcity and conditional abundance to actively shape a United States-aligned global technology ecosystem. The VEU program is not a defensive tool, it is an offensive one, explicitly designed to incentivize foreign firms to adopt American AI standards and lure nations away from China's technological sphere of influence. It is a quiet but determined campaign to write the rules for the entire global artificial intelligence economy, with access to compute as the primary enforcement mechanism. For Beijing, America's export controls were a Sputnik moment, a clear and urgent signal that its technological future could not depend on foreign supply chains. The restrictions triggered a massive state-directed campaign for technological self-reliance. Chinese tech giants like Baidu, Alibaba, and Tencent, who had previously been content to purchase superchips from NVIDIA, were now forced by circumstance to turn to domestic alternatives. This created a vast protected market for China's own national champions. At the forefront of this charge is Huawei. Once crippled by United States sanctions in the smartphone market, the company has reemerged as the leader of China's artificial intelligence hardware ambitions with its Ascend series of chips. And while its technology still lags behind NVIDIA's absolute cutting edge, the gap is closing with startling speed. Independent analysis and claims from Huawei suggest its Ascend 910B chip, manufactured in China by SMIC, now offers performance comparable and in some tests even exceeding NVIDIA's A100 chip from 2020. All right. So what is China's SMIC? So China has a Semiconductor Manufacturing International Corporation. It's a major Chinese chip foundry, and so it's partially state-owned, publicly listed Chinese pure-play semiconductor foundry company, and it is the largest contract chip maker in mainland China. So China has its own Semiconductor Manufacturing International Corporation now, and its headquarters in Shanghai and incorporated in the Cayman Islands. Okay. now offers performance comparable and in some tests, even exceeding NVIDIA's A100 chip from 2020. The A100 was the workhorse that powered much of the generative AI revolution, so achieving parity is a major milestone. As a result, major Chinese firms are now buying and deploying Ascent chips at scale, building out domestic software and hardware ecosystem that could one day rival America's. Scarcity has also become a powerful motivator for innovation. Cut off from an unlimited supply of the best hardware, Chinese engineers are now forced to become ruthlessly efficient, learning to, as one analyst put it, squeeze every little bit of IQ out of every flop. The most stunning example of this is DeepSeek, a Chinese artificial intelligence startup. In early 2025, it announced it had trained a highly competitive large language model for a fraction of the cost and compute that Western firms like OpenAI were thought to have used. They achieved this through algorithmic efficiencies and architectural innovations born out of necessity. Alongside this forced innovation, Chinese firms have pursued other strategies to weather the storm, including stockpiling massive quantities of chips before sanctions take effect, smuggling, and using complex networks of intermediaries to acquire the hardware they need. The United States has placed a bold, high stakes bet, but a growing chorus of analysts and industry leaders are asking a critical question. Is this the strategy actually working, or is it destined to backfire? The core critique is that by cutting China off, the United States has inadvertently solved Beijing's biggest industrial policy problem. It has eliminated the incentive for Chinese companies to buy American products and has created a massive protected domestic market for Hawaii and other homegrown firms. This policy, designed to slow China down, may actually be accelerating its journey toward complete technological independence. The long-term risk is that in trying to hobble a competitor dependent on its technology, America ends up creating a fully independent, state-backed, and far more formidable rival with its own complete technology stack, rendering all future controls irrelevant. And there is also a direct cost to American leadership. United States companies like NVIDIA are being cut off from what was a multi-billion-dollar market. That lost revenue is money that would have been reinvested into research and development to maintain America's technological edge. Furthermore, the constantly shifting rules create deep uncertainty for global customers, damaging the reputation of United States firms as reliable partners and potentially pushing neutral companies toward Chinese suppliers in the long run. The broadest concern is the geopolitical fallout. The strategy risks cleaving the world into two competing and incompatible technological blocks: a digital iron curtain separating a United States-led spear from China-led one. This technological bifurcation would force every other nation to choose a side, fragmenting global supply chains, stifling international scientific collaboration, and potentially making the world a more dangerous and less prosperous place. The battle for compute is a central battlefield of the 21st century great power competition. The United States has designed deployed a powerful, sophisticated new form of statecraft: compute diplomacy. It is a strategy born from a unique moment in history where control over a few choke points in a globalized supply chain has granted one nation unprecedented influence over the defining technology of our time. This strategy is already expanding. The same logic of choke point control and tiered access is now being applied to other emerging technologies, from quantum computing to biotechnology. The fight to close the cloud computing loophole remains the next major front in this evolving conflict. The United States has made its move. By weaponizing the very building blocks of artificial intelligence, is it strategically cementing its leadership for the next century? Or has it lit the fuse on a technological arms race that will permanently fracture our digital world with consequences we are only beginning to understand?